So this topic is one that's near and dear to my heart because I get asked this very, very frequently. And it's about uploading media to S3 from web and mobile applications. So if you were here for a while, you still know that I'm James Bezic. If you're new to joining us just now, I'm a developer advocate along with Chris Munns here in the Serverless DA team. The most important thing on this slide is my email address and my Twitter handle. So if you have any questions about serverless, please feel free to reach out to us anytime and we'll do our very best to help. So we've only got 25 minutes to cover this, and there's quite a few different aspects we want to talk about, but there's three main topics. One is the challenges of handling user-generated content from mobile and web apps. Then we'll talk about how S3 can help solve this problem fairly easily. And then a lot of this will be live coding where I show you a solution and we can walk through exactly how it works. So if you're building web and mobile applications, you've probably come across this type of pattern. I built this application called Happy Path, which you'll find at the URL on the screen. And this allows users to upload photos at geographic markers depending on where they are. And this sort of upload pattern is very common. People have their phones and they take a photo and upload it to your application. But this is surprisingly hard to manage when you have a web or a mobile application that goes to tens or hundreds of thousands of users. And so traditionally, when you're using a server to manage this, it's a little bit tricky because often your server is doing lots of different things. It may be handling the building of pages. It may be handling user authorization and other tasks. And so when you look at images that are being uploaded to your server, these can be 2 to 10 megabytes each from any sort of modern phone. And this really starts to compete with resources on your server, such as network bandwidth as well. So when you look at this example, when a user uploads a photo to a server, typically you'd save it to some sort of local disk storage first, and then perform some processing and save it on to some persistent storage afterwards. And this can be very difficult to scale because when suddenly lots of your users arrive and want to do uploads at all the same time, you have to scale out these servers to make this work. So it's actually surprisingly tricky. And when you run an application at scale that handles uploads, you tend to find that a surprising amount of resource is being put to just processing the uploads. Now, one of the great things about using S3 and Lambda is when you build these workload solutions, you can combine the characteristics of both services in your workloads. So just to quickly review this, S3 is object-based. It provides 11 nines of durability, and it has virtually limitless storage for your workload. It provides lifecycle management, so you can expire objects and move storage tiers based upon rules, and it supports encryption and provides a fine-grained permission model. Lambda is the functions as a service offering at the heart of the AWS Serverless portfolio, and it provides 1 millisecond billing, so you're charged for the length of time that you use the service. You can configure memory, which also controls the amount of virtual CPU being used by your code, and it supports a number of different runtimes, including Python, Node, .NET, Go, and Java. And you can also bring your own runtimes too using custom runtimes. So we have customers running PHP, Erlang, COBOL, many others. Lambda is stateless, it scales automatically, and it's event-driven. So bear these things in mind when you're building your workloads because you can get the characteristics of both services without having to use custom code. So when you look at serverless uploads with S3 and Lambda, it's a little bit different to what you might be used to when you're using a server. There are 2 steps involved. The first is that you need to use API Gateway to make a request to a Lambda function, which requests a pre-signed URL from S3. This is then returned back to the client app. And this is purely just a URL that you're then going to use in the second step to upload the binary data directly to S3. So it's really broken out into 2 separate steps. In this example, the getSignedURL function looks a little bit like this. And we'll get to this in the code, but I've highlighted the key parts here. So all of this function is really doing is it's building a params object, which contains the bucket name, the key name, and the content type, which in my example will be a JPEG. And it's also including an expiration value here. So we're picking 300 seconds. And that defines how long that this upload URL will be available for you to upload a file to that location. Once you've built this params object, you then call the getSignedURL method in the SDK. Now, if you're using Node.js, you might be using async await syntax. So here I'm using the getSignedURL promise method, which can help make the code a little bit more readable. Once that returns, we have our upload URL and our key, and that gets returned back to the front end, ready for the next step. So what are the benefits of doing this over the other approach with a traditional server? Well, first, the client is uploading directly to Amazon S3. They're not going through any sort of proxy in the middle, such as API Gateway or Lambda or Server. It's literally talking to the S3 service. And so this offloads all of your network bandwidth and compute away from your workload to the S3 service. S3 is massively scalable. So if you have the sort of mobile app or web app where you've got users distributed all over the country or the world, this can actually scale to meet all of the uploads that are coming to your application. There's also no intermediary temp storage. So in that example I showed with the server, the image was being saved locally to the server as a first step. And if anything went wrong there, what you would find is you just lost the image. Well, in this case, the image is durably persisted at S3. And of course, when your image then arrives within S3, that put object event can also trigger a Lambda function. So you can use this to build extensible applications based upon the upload itself. If you're building workloads where you have to worry about the security of the object, you want to make sure it's only accessible by the right people, or you have to look after it in certain ways. S3 has really complicated security settings you can use that can really bring all sorts of different permission models to your applications. So it's not something you have to build in with custom code. You can set that as bucket settings and IAM policies around your workload.
I'll hold you real quick on that one. So you said really complicated policies, but I would prefer to use the term really flexible policies, right? So
yes,
with what you could do with IAM and the permissioning around S3, and insofar as some of the examples that James has given around, configuring mobile applications, web applications, applications where you could have users that are all over the place accessing or needing to do what we're talking about here, which is upload data to S3. You can get very specific and really very fine-grained out across what's called the path of the object in S3 that you can do specific permissions on. And so you have a really great way to say, who or what can write to what part of effectively the namespace in an S3 bucket. Again, who can read from that and be able to control it, I would say, on par or better than what you would typically see with a shared file system mount, for example.
Yeah, absolutely. And there's several things you should remember when you're using this. So a pre-signed URL contains this authorization token that expires. So when your front end makes this request for the token, that expiration time you provide determines the lifetime of that token. So you've got that period of time to upload. So you want to make sure you set an expiration that is appropriate for your use case. Also, the Lambda function that made the request for the pre-signed URL must have put object accessed on the bucket. From the code examples, you see that I've put this into the SAM template, but it's often easy to forget that the Lambda function itself has to have this permission. You can also upload any type of file. So I'm focusing on JPEGs, but you could upload PDFs, zip files, whatever you prefer. And although S3 objects, when they're first uploaded, they're private by default, you can also make them public. So in some mobile apps in particular, this can be useful, especially if you have user-generated content that you want to share with other users. So let's take a look at how you make those objects public. So in the params object that I showed you in the previous function, all we have to do is add this extra attribute, setting the access control list to public read, and that's how you make it public. You also have to remember that if you're then defining permissions for your Lambda function, you want to make sure that it has the put object ACL attribute as well, because that's something else the Lambda function will need to do in order for this to work. So let's take a look at the code. That's going to be the good part. I just find which window I have, Chris. Okay. So the examples for today are at this GitHub repo. I'll share with you a URL at the end, so don't worry about writing down.
I'll paste it in.
Oh, you'll paste it in? Great.
Yeah, I got this.
Fantastic. And what I've done is I've taken this GitHub repo and I've already copied it to my Cloud9 instance. Cloud9 is an IDE that runs in the cloud, and you can find it in your AWS console. So I've git cloned this to a directory called S3 uploading. And there's two parts to this solution. There's a front end that I'll show you in a minute that lets you test how the uploading works. And there's the part that is the architecture I showed in the deck. And we're going to look at that first. So first of all, this is a SAM template. SAM is the serverless application model, and it helps you to build serverless resources in the cloud. It makes it easier than doing it manually within the console. And since we're building things that involve more than one resource, we have S3 buckets and Lambda functions, this is a convenient way to deploy those applications. So in this template, the first thing you'll see is an HTTP API. This is a new type of endpoint that's part of API Gateway. And it has here a CORS configuration. This is something that's really important to remember when you're working with web apps. You need to make sure you configure your CORS settings. This setting here is a development setting where we're using star permissions. In production, you want to lock this down to the domain name that you're using in prod. A little bit further down, this is the code that's going to go and make the request for the pre-signed URL. And so this is stored in the code URI attribute. You'll see it's in the get signed URL folder just here. And we'll look at that in just a second. It's a Node.js function. We're going to give it a timeout of 3 seconds. This doesn't need much memory, so I've used the minimum setting of 128 megabytes. It needs to know the name of the S3 bucket, so we've passed that in as an environment variable. It also needs the access policy we talked about. It needs to be able to write to that bucket. And finally, this Lambda function needs a trigger. Remember, an event is needed to invoke a Lambda function, otherwise nothing happens. So in this case, that HTTP API endpoint with the path of uploads is what we're going to use to make this request. Now, the code itself is similar to what we saw on the slide. If I just scroll down a little bit. Here is the handler, and all it's doing is going to call this function called getUploadURL, which is a function just down here. Now I've set this up so that the function that decides what the key name is going to be called. I think this is generally a good idea to have your backend decide on object names instead of the front end. I'm just picking a random number, but you could have more sophisticated logic for your naming conventions. This creates a key, which is the random number with .jpeg on the end. And then we build this params object. So we have the upload bucket name and the key. That expiration value, which we talked about earlier, but just at the top, it's defined as 300 seconds just there. Then you have to set a content type. So in this case, it's image JPEG. And I've commented this out, but you could easily use this where this is the ACL that makes the object public. So if this was set, you'll be able to then immediately access the object on the internet. Once this params object is built, you can then call the getSignedURL method. That returns the URL that we need, and then returns that to the HTTP API and the caller. Now, to show how this works, I've already deployed this application. So I'm going to call this with Postman, so you get a sense of what it looks like. So I have Postman here. Now that is my URL. It might be a bit small to see on the screen, but it's not actually important because you need to see what is returned by the URL. I'll just make this a bit bigger. So that call comes back with a 200, indicating it was successful. And this JSON object, which contains the upload URL and the key name. Remember, the key name is generated by the function, not the front end. So the upload URL is this very, very, very long string with a security token attached to it. And you'll see from the beginning, it's uploading directly to S3. Now I can use this, if I just highlight this, I can make a request using Postman. I'll take that URL, that long string. It has to be a put. And then I use the body, set that to binary, and I'm going to select a file on my machine. I'll just take my headshot there and click send. So I'm putting a request to using Postman to that URL. And what you'll see there is we've got a 200 response indicating that worked. So if I go to S3 and look at that bucket that was created, let's go to the S3 service. I've got a number of buckets I deployed today, so I'll just find that bucket for that function.
Yeah, there's a lot in this account. So real quick, while you're digging that up, we've had a couple of questions I just want to come back to. There was a really good question about how do you determine the amount of memory to configure your function for us. You had mentioned that you were using the minimal amount for this one. Obviously, that's based a little bit on not necessarily doing any performance tuning today, and B, that is just kind of the default. But typically what you would want to do with something like this is test a number of different configurations. And now we did have shared in here the awesome tool that's built by Alex Calsablani here at AWS and a number of people in the community, which is Lambda Power Tuner, or Power Tuning, I should say, which actually lets you run a Lambda function with a number of different configurations against a given payload or event structure and see what gives you the best performance for cost breakout. And so there are places where maybe you do want to tune the function to be really fast. There are some workloads that you don't necessarily need it fast. So there's kind of, it comes down to what you actually might need. And some people might be saying, well, why would I not want it to be fast? Again, you pay based on the memory configuration and the duration of the function. And so depending on what you're doing, it might be that you're happy for it to be slower and use less memory. Or you might want it to use a lot of memory and be really fast. But again, it comes down to what that workload is.
Yeah, absolutely. And so what we see in the bucket, that file name with that object key at the end has been uploaded, not the original file name, but the key that we randomly picked. So that object has now appeared in the bucket. But let me show you how this works also from a front end. So that's how we do it with Postman. And that's a really good way of testing what you've built in the back end to make sure that it's working as expected. But from Cloud9, in that repo, there's a front end directory where there is a little bit of HTML that uses Vue.js just to create a couple of buttons for us to upload that image. Now what I've done is I've pasted that URL that was part of my deployment into this line 29. And you'll see when you download this is blank, so you need to paste that in there. And then what we can do, we'll go to this front end directory. Now I want to copy this up to my bucket. So I've just got a command here I had earlier. I'm going to copy this index HTML up to my deployment bucket for this application. I'm also going to use this switch where I set the ACL to public read. And so that there is copied that up to that bucket. And once you go to the bucket, you'll see that this index HTML file exists. And what it's got, if I just open this, that gives us essentially a website within a bucket. It's a very useful feature of S3 for us to quickly host something. Now, if I select the same image, I'll just bring up a random image here. I'll just pick a picture of me, my hat, which is one of the most popular with people.
We had a good question here. Someone was commenting, and we talked a little bit about this before, of using different S3 buckets as one almost kind of like a blast radius containment for avoiding loops.
Yeah.
The other is around simplifying a little bit security and permissions around who or what accesses the data inside of a bucket. And so a question here from Surly Dev about this. You could theoretically do everything in a single bucket, being really cautious about the key space of what you name those objects. Again, one thing we talked briefly about before in the intermission, as it were, with Robert, was you also opened up the potential that you could create a loop in Lambda where you write to the same bucket that you read from, and you basically kind of create an infinite loop inside of Lambda that will keep spinning and spinning and spinning and spinning for all time. And so that's what you want to potentially avoid. And so one safety mechanism is just use two different buckets or multiple buckets as part of a process like this. The other, again, would be really, really, really good about namespacing where objects go at any point in time. And maybe I'll try to show this in the next session when we talk about AWS SAM and we configure the event trigger. But in there, you could specify, for example, the path that you invoke a Lambda function based off of. And so you do have the ability to control it. You can be really fine-grained with it. But using multiple buckets is kind of considered like a baseline best practice.
Yeah. And so this front end shows a message saying that's been uploaded to the bucket. And sure enough, if we were to look at the bucket, we'd see that it's there. But I just wanted to call out two things that are often confusing when you're building this into the front end. And so in that index HTML file, what you'll find is there's two steps to this process. Your front end needs to make a request to API Gateway to get that signed URL. And then once it has that signed URL, then you have to make a second request to put the binary data up to the signed URL. So if you do those two things, then your front end can then pull the image and display it, or whatever else it needs to do. But if you're a front-end designer, definitely take a look at the index HTML file, because that has a lot of useful information in there. All of the code examples we're showing today are at this URL, s12d.com/s3 lambda. And so just to quickly summarize some of the benefits of this approach when you upload files to S3 instead of using a traditional server for web and mobile apps, this is very scalable. So if you have spiky usage in a web or mobile app, S3 will absorb that traffic, and Lambda will also scale up for pretty much any level of requests you can imagine. It's event-driven, so the events itself cause everything to happen. You're not paying for idle servers sitting around doing nothing. You're actually paying each time a user uploads an object. That also makes it easy to attribute the cost if you're building applications for customers. You can also use IAM policies, bucket policies, and access controllers. And if you apply the principles of least privilege, this can be a very secure way to build an application without needing a lot of ongoing maintenance. And of course, it's serverless, so there's no instances to patch or infrastructure to worry about. You can focus on the code and let AWS manage the rest. This is probably a good time to mention also Serverless Land for learning more about this approach. So this is a DA-managed website where we collect blogs, videos, learning paths, and other resources. And there's lots of materials there to help you learn more about building applications serverlessly. So my name's James Besnick. I'm a DA on the team with Chris Munns. Those are my contact details. And that's a very fast introduction to uploading media to S3. But if you have any questions, just let me know.